Hi children, today you are going to learn 8th class, 8th chapter, that is Exploring Geometrical Figures, in that exercise number 8.2. In this video mainly we are going to be focused on the topics of symmetry. What is symmetry? What is line symmetry? What is point symmetry? And what is rotational symmetry? How many kind of symmetries are there and what are they? How to calculate the axis of symmetries, an angle of rotation and order of the rotation, it is a rotational symmetry or not, when we can say it is a point symmetry. These topics, along with that, about some patterns which are called tessellations. Regarding that, one by one we'll be discussing and we'll complete this 8.2 exercise in this video. So let's go through the symmetry first. The meaning of symmetry, we are very familiar with the meaning of symmetry. Says, if an object is able to be divided into two or more than two equal identical parts, then it is called as a symmetrical figure. See, take any object. If that object is able to be divided into more than two or more than two equal identical parts, then the figure is known as symmetrical figure. Suppose, let me take a face of a human being. This face can be divided into two equal identical parts. Yes, at left side and right side, if you see clearly, it will be divided into two equal identical parts. There is no even a small change of either side. Then, our face of a human being and some of the animal spaces will be symmetrical. Yes, I hope you understand the meaning of symmetry. If any object is able to be divided two or more than two equal identical parts, then it is called as a symmetrical figure. So here, to be understand symmetry, I'll be taking it into some geometrical figures. First of all, the symmetry is divided into the three types. The symmetry is in three types. The first one is line symmetry. The first one is line symmetry. This into three types. The first one is line symmetry. What is line symmetry? It's also known as axis of symmetry. Line or axis of symmetry. Suppose I have taken a geometrical figure as a square. See that? Take a square and draw a vertical line. It divided into the two equal identical parts. See that there is no even change. It divided into the two equal identical parts. And taken a horizontal line. Now it's also possible. It's also divided into the two equal identical parts. Now you take a diagonally. Yes. Now see that 1, 2, 3 and 4. It has 4 axes of symmetry. A square is 4 axes of symmetry. A square is a 4 axis of symmetry. That means if you draw diagonally or vertically or horizontally, it will divide into equal identical parts. If I take a equilateral triangle, what kind of triangle it is? Equilateral triangle. If I take a equilateral triangle where all these three sides are equal. So see that from vertex to opposite side, you always remember that from vertex to opposite side, we can draw a line when opposite side is equal. That means all the sides are equal, we have to go for this. From vertex to opposite side. Only a regular polygons. Triangle is a regular polygon, I can say, because if all the sides and angles are equal, it is called as a regular polygon. In the square, all sides are equal and all angles are equal. So it is a regular polygon. In equilateral triangle also, all angles are equal to 60 degrees and all the sides are equal. In the case of regular polygon, if you want to draw the axis of symmetries, from vertex to opposite side you draw it. From vertex to opposite side. From vertex to opposite side. A straight line if you draw, it will divide. See that a triangle is 3 axes of axis of symmetry. Okay. Then I will be taking one more. It is a rectangle. It is not a regular polygon. It is a irregular polygon because all the sides are not in equal length in the rectangle. If all the sides and angles are equal in the length, then it is called as a regular polygon. All angles are equal but not all sides, so it is not a regular polygon. See that, however, we need axis of symmetry, that is line symmetry. See, if you draw a vertically a line, it divides into two equal identical parts. It is divided into two equal identical parts. Hence, it is a one line symmetry, and also I can also go for horizontal line. Yes. Now only a vertically and horizontally we can draw. It is a two axes of symmetry. Axis of symmetry or line symmetry, whatever you can see. A square is 4 axes of symmetry. A equilateral triangle is 3 axes of symmetry. A rectangle is 2 axes of symmetry. Here we need to be understand what is the meaning of axis of symmetry or line symmetry. Both are same only. So, if an object is able to be divided into 2 or more than 2 equal identical parts, the object is known as a symmetrical figure. That means here square is a symmetrical figure. The dividing lines is known as a axis of symmetry. Here square is, the dividing lines is known as a axis or lines. How many lines here? Vertically, horizontally and diagonally. A square is 4 axes of symmetry or 4 line symmetry. Equilateral triangle is 3 axes of symmetry or 3 line symmetry. Here a rectangle, a irregular polygon, it has 2 axes of symmetry. In the same way, you take any figure or any alphabet, in how many equal identical parts we can divide it? By using vertical line or horizontal line or diagonal lines, whatever. Okay, if I take a square, circle, see that I can divide into a many axes of symmetries. So, how many lines of symmetry? It is infinity. Infinity. That means we cannot count that how many axes of symmetry it is. There are lot of axes of symmetry will comes. It will divide into the more than n number of equal identical parts. N number of equal identical parts. So I hope you understood what is meaning of a line symmetry. The dividing line to the object is known as a line symmetry. So this is what, and we'll be going for the next one about rotational symmetry. So this is what we need to be understand very clearly. I'll be telling you, try to understand what I am going to be explaining you now about rotational symmetry. The first one is a line symmetry. The second one is rotational symmetry. What is rotational symmetry? See that every object can be rotated. Every object can be rotated along through the center point. You will see a man can be rotated, a bench can be rotated, yes, a board can be rotated, a pen, a pencil, a object, a book, yes, a chalk piece. Every object can be rotated, but every object cannot be called as a rotational symmetry. Need to be understand, everything can be rotated through the 360 degrees. If you rotate an object, if you rotate an adjuster, it comes into the rest position after completing the 360 degrees. Yes. Now it is a vertical chalk piece. If I rotate with an angle 0 degree, 1 degree, 2 degrees, 10 degrees and 90 degrees, then I will be going through the 180 degrees. Now it came to the rest position, the same position again, the vertical. Again, if I complete at the 360 degrees, again, if it is completed 360 degrees, it comes to the rest position. So, here a chalk piece is a rotational symmetry. How can I say it is a rotational symmetry? And if I take a bench, imagine there is a bench in my hand, I am rotating it. Okay. So, a bench is also a rotational symmetry. Then we'll take a man, suppose just imagine there is a person in our hand, we are rotating him, or not the idol, or not any statue, you take it and rotate it. You rotate through the 360 degrees, it will come to the rest position as it before. Same. Now head is here, will be rotating like this head, and the head comes to the same position after rotating 360 degrees. Yes. But a man is not a rotational symmetry. A man is not a rotational symmetry. So every object can be rotated, but every object is not a rotational symmetry. There is a some process to tell to the rotational symmetry. So I will tell you that, suppose to be explained about the rotational symmetry, I have to tell you that two more things, like what is angle of rotation, what is order of rotation, and number of axes. Suppose let me take here a square. Listen very carefully. A square, it is a now how many number of axes of symmetry? Number of axes of symmetry, angle of rotation, order of rotation. This means we need to be understand one is interlinked with the other one. You know that a square is diagonally, vertically, horizontally. It is a 4 axis of symmetry. The angle of rotation formula is that 360 degrees by a 4. Okay, it will give us 90 degrees. Yes, 360 degrees into 4, 90 degrees. So the angle of rotation is 90 degrees. Suppose you take a square shape of cube and rotate 0 degree, 1 degree, 2 degrees, 15 degrees, 30 degrees, it will not becomes in the same as it before. When you rotate 90 degrees, it look like the same again. You rotate again 110, 120, 130, it will not look same as it before. When come to the 180 degrees, it look like same again. You rotate again at 270 degrees, it look like same. At 360 degrees again. So see that the angle of rotation 90 degrees, at 90 degrees it look like the same again. Again at 180 degrees, at 270 degrees and at 360 degrees. Yes. So see that the angle of rotation is 90 degrees of a square. That in the sense, when you rotate a square through the center point, it is give us the same as it before at the angle of 90 degrees. So it is called as a 90 degrees called as the angle of rotation of a square. Order of rotation in the sense, how many times it look like same as it before while rotating through the 360 degrees. While rotating a square, it look like same as it before at once 90 degrees, second 180 degrees, third 270 degrees and fourth one 360 degrees. 4 times it look like same as it before. So the order of rotation is 4. Yes, I will give you one more example. Suppose you take a rectangle. We know that rectangle can be divided into the vertically 2 equal identical parts and horizontally. Again it is a 2 equal identical parts. Vertically also you can divide, horizontally also. The diagonally you cannot divide it. Okay, it is two axes of symmetry. Two axes of symmetry. Then angle of rotation in the same. Suppose for a rectangle I cannot take here. I have a test book. It is in the shape of a rectangle. See, it is in the shape of a rectangle. When I start rotating like through the center point, so I will be changing it. See, it is in horizontally first. Changing with 0 degrees, 10 degrees, 20, 30, 40, 50, 60, 90 degrees now. It is not like as if before. Before it was a horizontally, now it is vertically. So it is not. 90 degrees, it does not look like same again. So when you rotate again, yes, at 180 degrees it look like same. Again you have to, at 270 degrees it not look like same. At 360 degrees it look like same as if before again. So I hope you understood now. The angle of rotation is that. So what is here? It is 360 degrees by number of axes are 2. 2 ones are 180. That means here 180 degrees is a angle of rotation. At 180 degrees it look like same, and also at 360 degrees it look like same again. So the angle of rotation is 180 degrees. The first one should be an angle of rotation. Angle of rotation is 180 degrees. And the order of rotation, how many times it look like same? 2 times. One is at 180 degrees, the next is at 360 degrees. Okay, next I will be taking here a scalar triangle. A scalar triangle. Scalar triangle is since here all these 3 sides are different in the length. So you cannot divide any axis here. It is not a symmetry first thing. It is not a symmetrical figure. It is not a symmetrical figure because it cannot be divided into the 2 or more than 2 equal identical parts. It cannot be divided into the 2 equal identical parts. It is not a line symmetry. Number of axes of symmetry nil. So angle of rotation, see, but we can rotate the scalar triangle. Now take a scalar triangle and rotate at 360 degrees. It look like same again. When you take a scalar triangle and rotate at 190 degrees or 180 degrees or 130 degrees, 150 degrees, 180 degrees, again 270 degrees, 360 degrees, again at 360 degrees at the rest position. Again when you rotate it completely at the 360 degrees, this scalar triangle look like same as it before. So the angle of rotation is only 360 degrees. Every object can be rotated. In the same way, scalar triangle also can be rotated. It look like same as it at the angle of 360 degrees. How many times it look like same? Only once. Only once. So see that from this now will be understand what is rotational symmetry. See that the rotational symmetry is that if the order of rotation is more than 1, it is called rotational symmetry. If order of rotation is more than 1, it is called rotational symmetry. See that if the order of rotation here more than 1 only, it is also more than 1. So here a square and rectangles are rotational symmetry. A scalar triangle is not a rotational symmetry. Instead of scalar triangle, if you take an equilateral triangle, where all these 3 sides are equal, A, B, C, it is an equilateral triangle. Suppose it has 3 axes of symmetry. If it is 3 axes of symmetry, we have to divide C 360 degrees by 3. So number of axes of symmetry 120 degrees. That means at 120 degrees it look like same. 120, 120, 240 degrees it look like same. 240, 120, 360 degrees. So the angle of rotation is 120 degrees. That means if you take a equilateral triangle and try to rotate at 120 degrees, it look like same again as if before. Again at 240 degrees, double of it 120, 240. 240 degrees it look like same. At 360 degrees again it look like same. So how many times it look like same? 3 times. So it is also an equilateral triangle is a rotational symmetry. Okay, I hope you understood the meaning of axis of symmetry. How many axes of symmetry we know it? How many? If you draw a line, it should be divided into 2 or more than 2 equal identical parts. Then it's called axis of symmetry. That is how many axes of symmetries we can count. Angle of rotation, nothing but how many axes are there here. We have to take 360 degrees by the number of axes of symmetries. You will get angle of rotation. That in the sense, angle of rotation in the sense, at what angle the object will give us same as it before. At what angle the object look like same as it before at starting. Then the angle is known as the angle of rotation. If order of rotation in the sense, how many times it look like same as it before while rotating through the 360 degrees, the number of times is known as a order of rotation. If order of rotation is more than 1, it is known as a rotational symmetry. See, one is interlinked with the other one. Here, if you want to know the angle of rotation, we have to know the 360 degrees by this number of axes of. You have to divide 360 by number of axes. You will get angle of rotation. How many times it rotates? How many times if angle of rotation 90 plus 90, 180, 180 plus 90, 270, 270 plus 90, 360 degrees. So how many times it look like same? 4 times. So here 1, 2, 3, 4. Here order of rotation is 4. If order of rotation is more than 1, it is known as a rotational symmetry. Suppose you take a person or idol or a statue, try to rotate. At 360 degrees, it look like same again, the idol or a man. Then the man is not a rotational symmetry. Mind it. Yes? So I hope you understood the meaning of a rotational symmetry. Rotational symmetry in the sense, if the order of the rotation is more than 1, it is called rotational symmetry. That's it. If order of rotation is more than 1, it is a rotational symmetry. To know the order of rotation, we should know the angle of rotation. If you know the angle of rotation, if you want to know this, you have to know the number of axes of symmetry. Yes? So you have to know all this. One is interlinked with the other one. Then we'll be discussing about next some point symmetry. We'll be discussing about the point symmetry. Next, the third type is that point symmetry. There are some figures which are not axis of symmetries. There are some figures, it's not an axis of symmetry. We cannot be divided into 2 or more than 2 equal identical parts. Okay, try to understand. There are some figures which cannot be able to divide into 2 or more than 2 equal identical parts. It is not a symmetrical. Okay, then there are some objects which cannot be divided into 2 or more than 2 equal identical parts, even though they are called symmetrical objects sometimes. How? Just now I told that if an object able to divide into 2 or more than 2 equal identical parts, they are called symmetrical figures. But there are some special kind of figures which are not axis of symmetries, but they are symmetrical figures. How? Which kind of figures? Let me recall. There are some figures which look like from top view and down view or side views, it look like same, then they are called as a point symmetry. The figures which looks from side view or down view or up view, okay, up view or down view or side views, if you see an object, it look like same, which cannot be divided into the equal identical parts, but it look like same when you see the side view or top view or down view or side views, whatever, it look like same, then such kind of figures are known as point symmetry. They are point symmetry. I'll show you some point figures here which are there here in the textbook. I hope you can see here one picture. Here this is a picture is a point symmetry. When you see this figure, you can tell that from the side views or top view, we can feel the same figure, but we cannot divide into 2 or more than 2 equal identical parts. But see here, there are some more figures which are point symmetry too, which are point symmetry, because here when you see from the top view and down view, they look like same. From this we need to choose what are the point symmetries. So the figures which can able to see from the top view and down view look like same, they are called as a point symmetry. There are some alphabets which look like point symmetry, like X is a point symmetry, it is an object alphabet, and H and I is a point symmetry, W is a point symmetry, M is a point symmetry, and N is a point symmetry, and S is a point symmetry. These are the alphabets or point symmetries. Remember, these are the alphabets are known as point symmetry. When you see the top view or down view or side views, it look like same. Here side views, this look like same. Yes, here top view and down view, it look like same. From the side views, it look like same. That means an object which are look like same from the top view or down view or side view, the objects are known as point symmetries. Sometimes point symmetries may be axis of symmetries. Sometimes the point symmetry may not be axis of symmetry. It is not necessary that it should be a axis of symmetry. Point symmetries, it is not necessary that there should be a axis of symmetries. That means line symmetries. There is no rule for the point symmetry. It should be axis of symmetry or not the axis of symmetry. Okay, it will be depends on that. Okay, then here the next thing we need to be discussed. They may ask you to, you may see the many patterns at your puja room where you do mothers or do the puja in puja rooms, or not in the tiles when you observe the tiles of your house. These tiles are in the same one basic geometrical figure. Some are the tiles in the square shape. Some of these tiles in the rhombus shape. Yes. Then here, all the tiles will be attached end to end without any overlap. So all the tiles are attached end to end. That means there will be no, suppose it is a place, here some tiles are adjusted. Here all these tiles are in the square shape. There is no gap between the tiles. Can you see, if you keep a gap between the tiles, it doesn't look nice. Nowhere it will shows like that. Okay. Then all the tiles, all the basic geometrical tiles will be attached end to end. Yeah? And you might be seeing there are some what we can say pictures. In that picture there will be some basic figure. There will be basic figure which are attached with the end to end like. And I will show you some patterns. There will be such a pattern will be attached end to end. I would like to be tell you about that, about tessellation. About tessellations, we have a question here about the tessellations. Yes, let me write here about here. I would like to show some tessellations here. Here you can see some tessellations. Here there is a one basic objects are there. In that octagon is used. Octagon, the side which has the figure which has 8 sides is known as the octagon. Octagon is a basic figure in this. Here in this hexagon is the basic geometrical figure in this. All the hexagons are attached end to end without any gap. In the sense, all these hexagons are congruent figures. To simple make you understand what is tessellation, I will tell you. If more than 2 or more than 2 congruent figures, congruent in the sense, you know that what is the meaning of congruent of the figures. The figures which have same size and same shape. If you are keeping one figure on the another figure, it should be occupy the same place. They are called congruent. If the congruent figures attached end to end without any gap, they are known as the tessellations. Simple. All the tiles of your classroom or not at your home or at puja room, all tiles will be in the same size and the same shape also. Yes. So they are called tessellations. See that I'll show you some more basic geometrical figures. Okay. Here you can see in the page number 199. Here these are the basic geometrical figure. All these called as the tessellations. So around you we might be observe all the tessellations. Nothing but tessellation in the sense congruent figures. The same figures attached end to end. The same figures are attached end to end to form a big figure. And this figure is known as a tessellations. In that the basic shape is the basic shape. What's the shape is there? That is a square is the basic shape. Sometimes there will be a regular polygon or not regular octagon, hexagon. Different basic shapes will be used in the tessellations. Okay, these are the topics are important in the this our in exercise 8.2. In 8.2 these are the topics is very important, and I'll be going to be draw here some English alphabets A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. See that Y should be written like this. Z. These are the uppercase alphabets. Actually, we have to draw like double bond letters like this. So it takes a lot of time to draw. So I'll be going for only one or two. I'm going to write here. We have to draw all these kind of. In this way you have to draw remaining all. Let's see how many axes of symmetries are each and every alphabet. Here A is a one axis of symmetry, B is a one axis of symmetry, D is one axis of symmetry. Sorry, C and D both are one axis of symmetry. E is one axis of symmetry. F is not an axis of symmetry. G is not an axis of symmetry. H is two axis of symmetry. I is also two axis of symmetry. J is not an axis of symmetry because J cannot be divided into two equal identical parts. K is one axis of symmetry. L is not an axis of symmetry. M is a one axis of symmetry. N is not axis of symmetry. O is a infinitely many axis of symmetries, and P is not axis of symmetry. Q is not axis of symmetry. R is not axis of symmetry. Here S is also not axis of symmetry, remember, and T is a one axis of symmetry. U is one axis of symmetry. V is one axis of symmetry. W is one axis of symmetry. X 1. When you draw the X like this, when you draw the X, see that 1, 2, 3, 4. A X is 4 axis of symmetry, and Y is that y should be drawn like this. Y is one axis of symmetry. Some of them they will draw the y like this, and hence they show that it's not axis of symmetry, but it is wrong. Y has one axis of symmetry and Z is no axis of symmetry. So I have written here clearly how many axes of symmetry each and every alphabet. So mind it, here these are the number of axes of symmetries of each and every alphabet. Yes, you draw the double bond alphabets like this. You draw all the alphabets so that you will be knowing. Why did I draw in the sense? There will be a questions based on this in our exercise 8.2. Let us start with exercise 8.2. There are some questions which we need to answer. So I'll read the question, automatically I will go for the answers also. Okay, then here the first question here. Cut the bold type of English alphabets capital and paste in your notebook. Draw the possible number of line symmetry for each of the letter. Written have divided into the each and every axis of symmetries. Let's see. How many letters have no axis of symmetry? How many letters are no axis of symmetry? Here F, G, J, L and N, P, Q, R, S and Z. These are the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 alphabets which has no axis of symmetry. How many letters have one line symmetry? How many? 1, 2, 3, 4, 5. Here A, B, C, D, E are one axis of symmetries, and H and I are two axis of symmetry. M is a one axis of symmetry, and T is a one axis of symmetry. U, V, W, X, Y, W, Y. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 alphabets which are one axis of symmetry. And how many letters have two lines of symmetry? How many letters have two lines of symmetry? H and I are two lines of symmetry. Third one, H and I. Here X is also they consider sometimes. They will be considered, this is also a two axis of symmetry, but it will be more than 2, and we consider more than 2 equal identical parts, we can divide the X. Yes, then how many letters have more than 2 lines of symmetry? More than 2 lines of symmetry are O and X. They have more than 2 lines of symmetry. Which of them have rotational symmetry? I already told you which of them are rotational symmetry. Okay, can you tell them what are the rotational symmetries here? As we know, the rotational symmetries are H, I, X, S and N, W, S and M. These are all rotational symmetry. So we are asking about the rotational symmetry. Sorry, these are the point symmetries. These are the point symmetries I have written. So let me go for that are the point symmetries. Sixth one answer: H, I, X, S, N, W, S, M. See that? And Z also. This is not a line symmetry, but it is a point symmetry. It is a point symmetry. See that N is not a line symmetry, but also is a point symmetry. H is a line symmetry. It is also considered as a point symmetry. I is a line symmetry. It is also considered as a point symmetry. That's why I told you when I discussing about the point symmetry, there are some objects which are not a axis of symmetry, but they are point symmetry. There are some figures which are axis of symmetry. They are considered as a point symmetry, and which are having rotational symmetry. Rotational symmetry in the sense simple. if the figure having two axes of symmetries, they are rotational symmetries. Two in the sense, see, HI is a rotational symmetry, O is a rotational symmetry, and X is a rotational symmetry. These are all rotational symmetries. See, N, you rotate like this, N you rotate like this, so it will be like Z, and it will be like this. So N is not a rotational symmetry. So when you try to rotate, imagine it, you get an idea. And S also, you try to rotate S, it comes like this, it comes like this, ultimately it comes like this, ultimately it goes like this, okay, and ultimately it comes like this, ultimately it comes S at an angle of 360 degrees. So it is not a rotational symmetry, because if it is a 360 degrees angle of rotation, it gives the order of rotation only once. It gives the order of rotation only once, then if the order of rotation only one, it is not a rotational symmetry. I hope you understood. And see that there are some pictures are given here. We have to know that either they are how many axes of symmetries each. So you need to be draw. Already I have shown you that how many axes of symmetry each of them. See that some of them I will try to draw here. A rectangle. A rectangle is a two axis of symmetry. First figure. Draw the line symmetry of the following figures. Identify which of them have a point symmetry. Is there any relation between the line symmetry and point symmetry? Yes, I already told you the relation between the line symmetry and point symmetry. If it is a one figure, and the second figure I will tell you again. In the second figure, I cannot draw the more than one here. Triangle. Okay, triangle is the second one. So all these are equilateral triangles. Okay, this is third one, and it is a second one. A pentagon is given next. Okay, from vertex to opposite side, from vertex to opposite side, from vertex to opposite side, from vertex to opposite side. 1, 2, 3, 4. From vertex to opposite side. 5. So a pentagon, it is a regular pentagon having 5 sides. Yes, this is the fourth one. So it has 5 sides. So 5 axes of symmetry. Okay, a regular polygon square has 4 equal sides. Okay, similarly you have octagon, ninagon, decagon. Simple. So a regular polygon. In a regular polygons, these all are in regular polygons. Square is a regular polygon, equilateral triangle, and a regular pentagon, hexagon, octagon, ninagon, decagon, like that. In a regular polygon, the number of sides equal to number of axes of symmetry. The number of sides equal to number of axis of the number of sides are 4, so it is a 4 axis of symmetry. Here number of sides are 3 equal sides here, so 3 axis of symmetry. Here regular pentagon having 5 sides, all these 5 sides are equal in length, so it has 5 axis of symmetry. If number of hexagon, if you take a hexagon where 6 sides are equal, hence it has 6 axes of symmetry. 6 axes of symmetry. The number of sides equal to number of axes of symmetry. That equal to that order of the rotation. That equal to order of rotation. Order of rotation. So it gives the same. The number of sides equal to number of axes of symmetry equal to order of rotation. And see, if number of axes is more than 1, number of axis is more than one, they are rotational symmetries. They are rotational symmetry. Okay, and what can you say about the point symmetry in the sense? If a figure is a axis of symmetry, definitely it is a point symmetry. Okay, if it is a axis of symmetry, definitely it is a point symmetry. If it is a axis of, if the axis is more than one, if a figure is having axis more than one, definitely it is a point symmetry. Okay. Number of axes is more than one, they are point symmetries. See, the number of axes more than one, so it is a point symmetry. It's also a point symmetry. It is point symmetry. It is point symmetry. It's also point symmetry. See that all these figures look like same from the top view or down view or side views. They are called point symmetries. So here number of axes are more than one only, so they are called point symmetry. If number of axes is only one, there we have to see either it is a point symmetry or not. There are some figures which are not axis of symmetry, but they are point symmetries. Okay, this is what I hope you can do it. Now here the third question is very simple. Name some natural objects whose faces have at least one line symmetry. Some natural objects which you see around you which has at least one line symmetry. See that book, which is in the shape of a rectangle, is two axes of symmetry. Your face is as a one line symmetry. Butterfly is one line symmetry, and a brick is a two lines of symmetry. Big brick. Okay, then compass box, and there are many things around you which has more than one line symmetry or one symmetry. So you can write many examples. Yes? That is what third question. Then the fourth question is draw three tessellations and name the basic shape used in your tessellation. So every tessellation used a basic shapes. I have told you that every tessellation used a basic shapes. You have to draw any three tessellations which you see around you, but see that all in the tessellations everything should be a congruent figures. They should be same. All these are congruent figures. All congruent figures are attached end to end, so it became a tessellation. So if at all you are drawing a tessellation, mind it that the figures which you are using, the basic shape which you are using, in that basic shape you should have same design. You should have same design. In the sense, they should be same congruent figures. If you are having a dot here and in the next place you should be have the dot there itself, then only it's called as a congruent. Same shape, same size, and to look this should be same. All these congruent figures attached end to end, it become a tessellation. Use some basic geometrical shapes in that, like a square, rectangle, rhombus or circles. Okay, see that when you are using circle, there should be overlap. There should be no gap also. If you attached all the congruent figures end to end without any overlap, they are called tessellations. You draw some tessellations by using your textbook. I already showed you, or not go through the net. You will be getting more and more tessellations. You will be getting an idea how to draw it. And I hope you understood this chapter, exploring geometrical figures. If you have any kind of doubt, just go through the textbook and you can ask me. I'll clarify in the comment box. Thank you.